You have kids. I think they're
Yeah.
relatively young, right?
Yeah, 1, 3, and 5.
Okay. So I don't know what your plan is, to kind of protect them.
I don't have a plan. Hey, everybody. Welcome to Doom Debates. Today, it's an honor to have a special guest, Dr. Keith Duggar from Machine Learning Street Talk. We're going to debate the issues that I raised in my previous episode, where Keith was talking about how theory of computation relates to LLMs and whether LLMs can truly reason. He's been generous enough to say that he wants to push back with me live. He's coming into the lion's den. So before we get started, Keith,
Absolutely.
thanks for coming on. Tell us a little about yourself and your background.
Well, I have kind of an eclectic background. I think, when I was a kid, I loved everything. I've realized now that my passions are really learning and problem solving. And so when I went off to school, basically I looked in a book of these top starting salaries for 4-year degree engineering majors, and the top two at the time were, I think, electrical engineering and chemical engineering. And so I chose chemical engineering. So I ended up studying that both in undergraduate and graduate school, but over that period of time, there was just more demand for software work. So I ended up minoring in computer science, and my research really gravitated more towards applied math and computation. I became disillusioned with the state of kind of, let's say, corruption and academic research. So I became essentially like a failed academic. I just couldn't ethically do it. So I decided, hey, if I'm gonna have to deal with corruption and politics, I'm gonna go somewhere where that's just openly and explicitly the goal. So I defected to the dark side, went to Wall Street. I was one of the kind of evil rocket scientists or whatever for 8 years or so. One day, my kids asked me what I did for work, and I said, well, I take other people's money and I move it around, and every time I move it, I take a little bit. And they thought that was an amazing job description, like, best possible job ever. But it got me thinking about just kind of how really empty what I was doing, was. So then I went to Microsoft and did a bunch of technology strategy for manufacturers, people doing real things. I met Tim there. So the co-host of Machine Learning Street Talk, him and I were both at Microsoft at the same time. He had this cool like paper review call that he had. I showed up there one day. We hit it off. He built this YouTube channel that I was really lucky to be a part of, and that's how we ended up here today.
Awesome. Cool. Yeah. Thanks for the background. Glad you found your way to computer science. For people who don't know, I studied computer science in college and then have been some form of entrepreneur or code monkey my whole life. Somewhat similar backgrounds. Keith, to kick things off, I think a lot of my viewers really want to know, what is your P-Doom?
Yeah, so when you ask me that, and by the way, I do not want to pretend I'm a doom expert. Okay, I mean I've gotten involved in these conversations lately, but I had to look up. Okay, what does doom really mean, right? In that scenario, and I see it means sort of different things to different people. And so if I take it as kind of Bostrom's original definition, which is essentially we lose out on our what do you call it, the cosmic endowment, right? Something really kind of catastrophic happens to the human race. I actually think it's 25% or maybe closer to 30%, but I don't think it's going to be due to a super intelligence. I don't think it's going to be directly due to a super intelligence that decides to cause us harm. I think it's much more likely that human beings are going to misuse super intelligence and kind of use it to destroy ourselves, if you will. Like we're already harming ourselves significantly by super intelligences, like in the at least narrow super intelligences. So narrowly super intelligent ad machines and attention grabbers and things like that. So
Mhm.
yeah,
Keith,
it's definitely
Poofer.
something that should factor into our politics and planning. And actually, one of the questions you had asked me, right, is whether I would sign that statement. And as soon as you sent it to me, I'm like, absolutely. I completely agree with it.
Right. Yeah. The famous statement on AI risk from the Center for AI Safety, mitigating the risk of extinction from AI should be a global priority alongside other societal scale risks such as pandemics and nuclear war. So we had this conversation offline, and I was like, what do you think of that statement, Keith? And Keith literally went on the website and signed it and showed me the email confirmation.
Yeah, yeah. I don't know if they're going to accept my signature. I guess, I don't know if I'm important enough or big enough to add it to their document, but absolutely I agree with that statement and signed it. So thank you for pointing me to that.
I gotta say, yeah, thank you for signing it. I gotta say, Keith, I was pretty shocked when we talked offline and you told me what your PDoom is, because have you ever said that on Machine Learning Street Talk?
No, so again, this doesn't come up so often, and two things about street talk. So first of all, it's a really contentious, or maybe contentious isn't the right word, but this rancor that we talked about earlier, right? Like if you get involved in this conversation, you can definitely expect some abuse, right, from any side. And so I think we sometimes tend to steer away from those, particular areas likely where we'll get abuse as much as we can. But also a lot of times I'm there to play kind of a devil's advocate, right? Like to at least interrogate arguments or to expose what I see or maybe the weak points of arguments. So I just think there's never been an opportunity for me really just to come out and state my own, personal position on it until now.
Fascinating. The other day I was talking on my podcast about like a taxonomy of doomers. And it starts with the first tier, which is like, Eliezer Yudkowsky, Miri, which I kind of count myself in that tier. But then we talked about people like Dario Amodei, who seem very cheerful, seem very normal. They're working on AI, like everything's fine. But you might call them closet doomers, right? Like you never know that underneath the surface, they have like a 25% P doom, right? What do you think? What do you think about that? Do
Right,
you think
right.
people should wear doom on their sleeve a little more explicitly?
Well, I mean, I think more attention is obviously being directed towards doom. I mean, it's almost phrasing it in terms of doom is maybe part of the problem, honestly, because doomerism is nothing new, right? Like there's been all kinds of doom. The Mayan calendar sort of spells doom, and some religious rapture is coming and it spells doom. And so I think in a way it almost kind of tarnishes the conversation because it gets associated with things like that. So apart from that, it absolutely needs to be a big part of our conversation. Like maybe it should be called, AI harm because I think almost nobody could deny that AI is harming us, now. I mean, it's if you've watched The Social Dilemma, right, the great
Right.
documentary, like it's harming us now, and these tools will continue to get more powerful. They'll if they're misused, the harm will increase. So I don't know if people should wear doom on their sleeve, but people should absolutely be talking about the harm that AI is doing now and how it can get much, much worse.
When you say AI is harming us now, would you still say that it's net positive?
Oh boy, that's a tough question. That's a tough question. I think that's a really tough question. I think I would say yes, but that may just be my bias for working kind of closely adjacent to it or in AI, and I think it may also be my failure of imagination to imagine alternate worlds where there was very less, AI. So I honestly can't answer that question, but there's a great uncertainty there. I just think it's inevitable. So I don't think there's any way for us to put the genie in the bottle, and so we have to wrestle it.
Well, this has gone in an unexpected direction because if you ask me whether I think AI is net positive, I'd be like, yeah, definitely. It's great, right? Like I use AI products all the time and like, okay, sure, yeah,
Right.
there's like some deep fakes coming out and we got to deal with them, but like in my mind, I think that it is just increasingly positive until we reach some threshold where it becomes uncontrollable or too destructive. And then at that
Mhm.
point, the graph kind of shifts from like up to like permanently down. That's how I see things.
Well, you could entirely be right about the net positive of AI. I think that's probably maybe even the consensus. I'm just saying I haven't done that analysis, and I haven't even really looked at an analysis of it. So I just don't know. And and I do agree again that there will come a point. There will come a point where these tools. Well, let's just put it this way: they're going to become increasingly powerful. There will be an increasing chance for harm and misuse. Um, I don't think there's going to be this FOOM event of super AI, which I think is maybe what you have in mind there, and then we can get into later. I think after we clear up some of the Turing things,
Yeah, yeah, yeah.
why I think that. But I don't think it changes the policy implications, which is we have to take this seriously. We have to invest money into it. We have to tax the industry to have enough money to do that. We have to put in place mitigation. So I have a lot of agreement actually with Joshua Bengio. So I think he called himself maybe a doom agnostic or something like that. But because of the probability of it and the uncertainty of it, he advocates for these mitigations, planning, taking it seriously, et cetera. I think that's probably where I would put myself. Though I think I actually have I'm less agnostic. I think human beings are absolutely capable of destroying ourselves, and we're already in that situation, and we should try to back out of it and not get into it with super intelligence either.
Awesome. And by the way, Joshua Bengio is on record implying that he has a 20% P doom. So that checks out that you're in the same ballpark.
Well, we're slightly more pessimistic because I think I said
Exactly,
25, maybe 30, right? Yeah.
Yep,
Like
yep,
for
yep.
example, there were some estimates that the Cuban Missile Crisis basically was, or I mean, it varies between 5 and 50%. But I think Kennedy was around a third of a chance that could have gone wrong, right?
Mhm. Yes, absolutely.
That's
Okay.
not good.
So, Keith, I think this is a major point of consensus between our two worldviews, which is it sounds like you don't think that humanity has plot armor, right? You think that we're allowed to die, correct? Like the author is allowed to kill us.
Oh yeah, 100%.
Okay. Right? Because I've
Well,
definitely
not
heard a lot of people.
actually.
Yeah.
Let me just say, not only are we allowed to die, actually, one of the other sides of this debate is if we don't develop super intelligence that we can adequately have aligned and controlled, we will die. I mean, we need super intelligence to escape all the various cosmic, death timers that we're on. So
Yeah.
it's a funny thing. We have to straddle this. We have to walk this tightrope.
It's a great point that on a billion-year timescale, everybody's a doomer. I mean, it's just an obvious scientific
Sure.
theory that, the sun is not going to make the Earth habitable in a billion years. Right. So the only question is, the question is when, not if, right?
Yeah, when not if, I agree with Elon Musk. We have to become a spacefaring, you know, civilization. We're going to need super intelligence for a bunch of tasks. And sure, on a billion years, the sun's going to turn into a red giant and engulf the earth or whatever its fate. But I think there are even shorter term things. There are
Right.
things like blowing ourselves up with nuclear weapons, some jerk getting enough ability to print a pathogen that kills off a lot of people, billions of people, maybe. I mean, there's a lot of ways in which we can die. So
Okay. All right. So now let me try to find a major disagreement because it sounds like we've hit on so many points of agreement. Like we both agree human existence is kind of fragile. Doom is a
mhm.
question of when, not if. Nukes are super scary. We might nuke ourselves. We might pandemic ourselves to death. Like I think we agree on all these background assumptions, and we also agree that it all nets out to a pretty high P doom. I mean, you say 20 to 30, I say 50. I'm happy to just say 20 to 30. I don't think there's that big of a difference. It's not like I have a
Sure.
lot of digits of precision when I say
It certainly
50%.
doesn't change the policy implications. Yeah.
Yeah, exactly. That's right. So let me try to dive straight into trying to get you to disagree. I think the heart of the issue is you kind of make claims about a boundary of what LLMs can and can't do. And I don't
Mhm.
really see it as a hard boundary. I don't have that same
Mm.
confidence and crispness that you seem to bring to the table. So do you want to just repeat the claim that you made on your podcast about what's the current boundary of what LLMs can do?
Sure. And we have to be a bit precise here because LLM now has come to mean a variety of things, okay, to a variety of people. And so let me just be more specific about what I mean by LLM, okay, so to me an LLM is a single neural network that has a finite context window that's run either once or autoregressively, okay, until it generates some stop token itself, until it outputs sort of an end of story, token, if you will. Okay, so just let's accept for now that's my definition of LLM. Okay,
Okay.
those things, okay, are finite state automata, and primarily the reason why is because they have this finite, context window and a finite sort of set of neurons, so they can only explore kind of a finite set of states, um, and therefore they belong to a class. And this is where I have to be super careful, and I kind of want to slightly reframe what I talked about in machine learning street talk for this conversation, because you have the background to get it, and I think it actually be clearer for other people. Is that, by historical accident, okay, the field of computer science refers to machines, all the time, right? So there's finite state machines or automata, there's Turing machines, etc. Okay, and why is that? Well, it's because those were the machines, and these are nomological, or nominal definitions of a machine. They're not
Yeah.
physical
I think I know
definitions
what
of a
you're getting at,
machine.
right? Are you going to like talk about like lambda calculus?
Well, no, what I was going to say is, they're called machines, okay, but what's actually more important, like the more important thing to focus on, is these classes of algorithms. Okay, so
Right.
you have algorithms, which we can just
Gotcha.
call finite state automata algorithms. And then outside of that, you have, context free grammars, push down automata. These are
Right.
algorithm kind of classes, right?
Right,
So
right,
what
right.
I'm
Yeah. So
saying is that,
computability theory divides functions into these classes based on whether they're
correct.
computable by certain models. So I'm following you. Yeah.
Yeah, yeah. So it's not like what I'm trying to say is LLMs are limited because they've got finite memory, and of course you could just go get more memory and add it. What I'm saying is that the class of algorithm that we end up training on LLMs belongs to the class of finite state automata, and therefore you can't just give it more memory. So, for example, if we suppose we have an LLM and we go try to do some problem that I claim it can't do, like give me the nth digit of pi. All right. So somebody, hey, everybody, I've got an LLM that gives you the nth digit of pi. Cool. Somebody comes in and asks for whatever, the 1 billionth digit of pi, and it runs for a while, and maybe it gives the wrong answer, or it outputs a token that says, hey, I've run out of memory, give me more memory, right? You can't give it more memory, because in order to expand its context window, what you have to do is retrain it, right? That's just the way in which we construct these LLMs and the way in which we train them. So I'm not saying that a neural network, so a Turing machine, a thing that can run algorithms of a more powerful class of algorithm. It's actually, and I really hate saying it this way, like it's just, but it literally is just this. It just doesn't do justice to Turing, right? And the real, genius behind this revelation. But it's just a finite state automata that has a unbounded read-write tape. Okay, and I am not trying to say, and in fact, I've said in the show more than once that finite state automata that's sitting there as the controller of a Turing machine can in fact be an NN. It can be a neural
Right.
network. It can be an LLM. It can be whatever, right? I'm just pointing out that it has to be able to utilize this unbounded read-write memory. And every time
Right.
people have tried to train them to do that, they've failed, because we just don't yet have, the optimization methods, the training methods to search the space of Turing-complete algorithms efficiently.
Okay. I want to give you some credit where credit is due. I'm going to concede a sense in which I agree you're right. And furthermore, I'm going to concede a sense in which I was wrong. So I feel like it's like so rare in debates for somebody to call themselves out and be like, I was wrong. That's like something missing in debates. But
Yeah.
yeah, so I will give that to you.
Right.
You deserve it. So
Okay.
here's the technical point that I messed up on last podcast. I was saying that if you look at something like GPT-4, where it just starts printing out output tokens, the claim that I made was if you just let it keep outputting token after token and you don't put a maximum limit on how many tokens it can output, I incorrectly said before that you can model it as a Turing machine because you have this unbounded output tape. My mistake was when I thought of it looking back on what it's already written, I forgot about the
Right.
finite context window. If it only has a finite context window, then the output tape isn't really infinite from its perspective because it can't look back infinitely far. It can only look back, whatever, a million characters back, and then it forgets what's before a million characters back. So it has
Mhm.
this limited window. And the problem with a limited window is when the output tape gets really, really long, what you end up seeing is you get cycles because there's only like 2 to the power of a million possible states that a million size memory can be in, right? So you
Right.
ultimately get a cycle. So
Right.
I absolutely concede that's not a Turing machine. That's a finite state automaton with a pretty generous finite memory size. But like I was wrong, you were right. Fair?
Okay, yeah, sure, sure. I mean, I appreciate that. So, I mean, look, I don't mind being wrong either, in fact, it can be kind of fun, right? Because we learn new things and really, like I said, my passion is learning. So I really respect that you said that, and I think more of us should, more of us should absolutely just be like, it's not you are not personally a bad person because you disagreed
Thanks.
with somebody and they happen to be right, I mean, it happens, folks. Like, it's better just to, "Oh, cool, I didn't know that," and then just move on, right? And let's make progress. Let's advance.
That's right. Losing points in an argument happens, guys. Okay, but now I
Yeah.
want to come back out swinging because I still feel
Okay.
like I'm right in spirit. Okay, now that I've conceded the technical point, in the example I used with like a million bit context window, that's
Mhm.
a large context window. That's a million bits of state. I mean, 2 to the power of a million is much larger than the size of the universe, right? So, like in practice, when you're doing anything useful, like when you as a human are thinking, do you really ever use more than a megabyte of context?
Well, I mean, maybe let's shift away from humans and just talk about our machines that we have now because it's really kinda crystal clear, So, for example, if you're a scientist at Los Alamos and you're trying to do simulations of, uh, these nuclear weapons, for example, that we've built and put all over the world that could kill us, right? Uh, you're going to be having terabytes of processing, right? I mean, even if you want to play a decent video game, okay, you're going to need 32 gigabytes of processing. So I
That's a
think
very good
my
point.
pushback would
Sorry, go
just
on.
be that, yeah. So I think my pushback is just that look, I get it. There's tons and tons of very awesome things you can do with a megabyte. I'm just saying it just is a matter of empirical fact. Many scientific and business and economic problems that we're trying to solve, they require more memory, you know?
Yes, I mean, you're absolutely right. But I mean, you use factoring as an example, right? If I gave you a pencil and
Mhm,
paper and I said, Keith, factor this 6-digit number, right? So like you'll get it
mhm.
eventually with a pencil and paper. In the entire process of you factoring that number, what would you roughly estimate? How much of that paper are you going to use in terms of bits of information? Seems like a lot less than a megabyte.
Well, I don't know that I've used factoring as an example because factoring is actually, factoring a number is something that you can do with reasonable amounts of memory, right? Because you can do it very slowly. You can just sort of go through and try kind of all the prime factors. And as long as you can just perform the factoring calculation on a 256-bit number or whatever, I think examples I've used are like arbitrary precision, math. And these things come up. So they don't come up in a lot of our everyday experiences. Tim challenged me this on the Discord. He's like, okay, LLMs can search program space, right? Because they can output programs. Give me an example of a program that can't be output by GPT, whatever its current sort of maximal non-repeating output is. And I said, okay, anything larger than its window stability, like how about the Linux operating system? Because the Linux operating system is a massive, many, many megabytes of characters, right? And
Right.
okay, fine, it can't output an operating system, but it can still do a lot. And I'm like, but see, these matter, right? Like these things are real programs that matter. Um, but of course, you're right in the sense that there are many, many, many things that we care about, many important problems that don't require those extreme amounts of memory. But if you were a super intelligence that wanted to take over the world, okay, and develop your own science and defeat the entire combined, power and capability of humanity, you're going to need more than a megabyte of memory, a lot more.
Yeah, okay, fair enough. But let's keep it to simpler examples first. Remember
Okay,
you
sure.
had this really interesting puzzle at the end of your episode a couple weeks ago. I don't want to repeat
Mm,
it now, but it's the one with like the rotating pillar, and it was fascinating. I
right.
tried it myself, and it made me feel
It's
dumb for a
fun.
little while because it was like so perfectly set up as such a simple puzzle, and yet the answer took me like an hour to finally get.
Yeah,
But
it's
even though I
fun.
used my whole human brain, right, and you showed how today's LLMs couldn't do it, right? So you that
Uh,
was a nice separator, right, between AIs and humans for today. I
right.
don't think that I used a megabyte of space during my thought
No, no,
process.
no, not at all, not at all. So, yeah, and there I was making, a different point, but okay, so what I was talking about, my intuition, let's say the intuition that led me to think that that particular problem, and by the way, it was just the first problem I tried, okay? So there's something about my intuition, that's right here. Like, I understand that LLMs, where they currently have difficulty, is they have difficulty in, computations that need to unfold precisely over windows. Okay. Like I can't, right now, let's say it struggled like this column problem sort of, it has 5 steps. It can be solved in 5 steps. Or at first I tried to give it some leeway and let it do it in like 8 steps. And that just made it like more confused. Right. So it can unfold over only 5 steps. Right. But these 5 steps have to happen precisely, and they have to happen in a dependent order in which they can, in order to be a solution, right? And I just thought, hey, maybe it'll have a problem with this, right? Because of that structure of the problem. We tried
Right.
out and it had a problem with it. I am not. So there will be GPT o something that I would bet could solve this problem because it's a sort of, very finite number of steps, right? Like it's just 5 steps.
Okay.
I would hope that O3 or something like that will be able to solve this
So,
problem.
do you think that this particular example that current LLMs are failing on, does this illustrate the profound insight that you're trying to share that current LLMs are not Turing machines, or is this illustrating something else?
It it's kind of illustrating c- both elements of Turing machines, but on the other hand, any finite problem, can eventually be solved by finite. I'll tell you what it's illustrating is. So I get a lot of pushback actually internally, even in the MLST community about, okay, fine, right? Like these things are not Turing machines, but it just doesn't matter in practice. It's irrelevant
Yeah,
in
that's my
practice
position.
because right. So all the problems I care about, and this is my argument when it comes to that, which is, okay, I think it does matter in practice, and I'll tell you why, which is, on the one hand, you have a class of algorithms, say those outside of finite state automata that can sit there and iterate on an unbounded, amount of memory. The critical thing there is not so much that it's a potentially infinite amount of memory, it's that the amount of memory is variable. It doesn't know ahead of time how much memory it's going to need. It gets a problem in, maybe it needs 500 kilobytes, maybe it needs a megabyte. It doesn't know in advance, right? So it has to have this capability to kind of go back and forth and perform these computations. And if instead you try to decide ahead of time, right? Like how much memory do I need to solve all the problems I care about? Okay, what you end up needing is an exponentially large amount of memory, right? So you can probably remember from computer science that every time step that you allow, you get an exponentially larger number of states, right, that you can explore because you always just sort of like a factor more, sort of per time step, right?
Uh-huh.
Um, and so therefore, any circuit that we try to build in this way, like as these finite state machines, is going to have this exponential blow up problem, which means the depth at which they can kind of think, right? The more you want them to think, you need exponentially more circuits per time step, if you will, right?
Right. I mean, if you model it as one big circuit, but I mean, isn't there an element of recurrence? I mean, we're looking at the model
Well,
of like
that's
it's
exactly
outputting
the
tokens. Yeah, but it
yeah.
gets to read what
That,
it
that,
outputted. So
well, that's exactly the whole innovation, if you will, behind
right.
behind
C-
O1, right? Is allowing it more time so it could do more with its and maybe even off. Yeah, go ahead.
I'm just confused because I think you just invoked this mental image where a single circuit to do a computation has to grow exponentially larger with the length of the computation. But in the case
Mhm.
of an LLM, it's not a single circuit. It just feeds back the current state of the tape into the original LLM. So you don't have to keep growing the circuit. You just keep having the circuit process the take.
Yeah, yeah. So it first of all, it is a single circuit. Like that was my definition of LLM, right? Like it's a finite
Right.
state automata that's run autoregressively. So it's a single circuit that's run on this tape with a finite context window. So I wasn't quite done. So I'm saying to people like if you try to take an algorithm that's a higher class than finite state automata and project it into finite state automata, it grows exponentially. Okay.
Okay, understood.
And OpenAI knows this, and that's why they're like, okay, we're going to start doing more inference time compute. This way we can do more with, so any particular circuit of a given size, if you can train it to run iteratively for a period of
Right.
time, you can do more, right? And so
I
they,
think I get what you're trying to say. And I think I agree with your technical point, which is that if you wanted to ask GPT-4 a factoring question, right? If you wanted to input a 10-digit number and you
Mhm.
wanted the zero shot output, right? You wanted it to just give you the answer on the first token, then you're correct that assuming factoring is NP hard, then you just need an exponential size circuit, right? Is that basically the point you're making?
Well, if you want to do it in one shot, you need an exponentially large circuit. If you allow it to iterate for every kind of number of iterations you do, you cut that down by a factor, right? So that, but then my point, which gets to the kind of rotating pillar problem, right? And is that we haven't yet mastered this ability of training an LLM that can reliably operate over longer context windows. It sort of approximately operates over longer context windows. And so if you give it a problem that requires these sort of multiple precise steps, those are the types of or one class. That's one class of problems that it will struggle with. Was my only point,
Right.
in that teaser.
Okay.
And
So
actually, by the
I'm
way, Yudikowsky makes the same point. So
really,
that, he was asked in an interview maybe a year ago or something like that, are LLMs the path to AGI, right? And the point he brings up is, well, they're not reliable enough to be, right? And it's kind of the same point I'm making here, which is if you have to unfold your computation over a bunch of steps and each of those steps is unreliable, the longer it is, the more likely you fail.
right. So I still think that when you use computability theory to analyze what LLMs can't do because of their finiteness compared to a Turing
Mhm.
machine, when that's the type of analysis you're doing, I think you could just do that exact same analysis about human brains. You could just say, hey, look, human brains can't really think because they're just finite state automata, right? A human brain can only ever get into a finite number of states, correct?
Well, so let's remember, and this is why I desperately want to reframe this in terms of algorithms rather than the machine. It's sort of, and again, it's really just if you're in the know in computer science, like this never really causes a hiccup. But when you're trying to communicate externally, it does. Which is, of course, my brain is a finite mass and has a you know more or less constant number of neurons, et cetera. Like what's up here in machine sense, like, or in physical sense is finite, but it's running an algorithm. It's running an algorithm from the class of Turing-Complete algorithms in that it can use external memory. So I can go grab a stack of paper, I can write down some symbols, I can use a chalkboard, I can use all this kind of stuff. An LLM, like the physical brain there, could do the same thing if we knew how to train it. Could do.
Okay. Let me ask you from this angle, just in terms of like, I still want to pick at your, finite versus infinite,
Okay.
automaton versus Turing machine distinction. Let me ask it this way.
Sure.
Imagine the smartest human alive, like Terence Tao, the mathematician, let's say.
Mhm.
Terence Tao can get a lot done in 1 hour, right? Like people report, they give him like their hard PhD problem and he's just like, oh, here's the answer, right? And oftentimes it takes him less than an hour. In that 1 hour, does Terence Tao really need more than a megabyte of working memory?
Well, to be honest, I've forgotten what the numbers are, in a human mind. I think it's a lot larger than that. I think it's more like petabytes, right? But I don't know. I mean, he definitely doesn't need an unbounded amount of memory. It appears if he's able to do it all in his head. right? I'm sure there are things though that he does that require paper. Like I'm sure whatever he's working on,
Yeah.
okay? And
So
this is
I
kind of the
mean,
point.
but what I'm saying is like, if you just model a 1 hour Terence Tao system, isn't that
Mhm.
just a finite state automaton?
As long as it's not using external resources, it's, yeah, but the algorithm he's running is a Turing-Complete algorithm, not a finite state automata algorithm. Does that make
But I
sense?
mean, but that's what computers are in real life, right? Computers are finite state automata that LARP as Turing machines.
Right, so this gets back to what I tried to point out earlier is, the focus right now that you're on is on the machine rather than on the algorithm that it's running, right? And I'm trying to say it's not so much the machine that matters, it's the algorithm that's running on that machine. And so, if I just imagine the old days, right, where I've got a machine, whatever, a Turing, let's call it a Turing machine, a giant box, okay? And there's two classes, not two classes, but let's just only consider two classes of algorithms that can run on there. Finite state automata algorithms and Turing machine algorithms, okay? And it has a tape deck. I know that the finite state algorithm will never ask me for another tape because it's just an algorithm that only needs like this finite amount of memory. Whereas the Turing machine is going to say to me, I need another tape, put it on there, add the next one,
Yeah.
add the next one, go back to the previous one, go back to. So it's not the physics of the machine. It's the nature of the algorithm that's running in
Okay.
it.
But if we talk about it from a complexity theory standpoint, like I'm going to ask Terence Tao a question, and he's
Complexity
not
or
going to.
computability, which are we on
Yeah,
now?
I'm gonna shift to complexity a little bit.
Okay.
So yeah, so if we talk to Terence Tao, he's not going to spin off an algorithm that requires an exponential search, right? He's not going to do 2 to the 100 operations during the 1 hour office hours that you have with him.
Hmm. Hmm.
So if we just know that whatever he's going to do is a reasonable, like polynomial time, or just like, okay, I gave him like a kilobyte of input and he's going to give me like a few kilobytes of output, and he's not going to spin off any super long process. It's just like, yes, you can say, hey, if we generalize the class of functions that he's doing, it needs infinite memory. But like realistically, you just need like an hour of Terence's time. Like you just need a few sheets of paper. You just need a few Google queries, right? Like you don't need anywhere near infinite memory.
I mean, I feel like you're just trying to say we can do amazing things with a finite amount of memory, and I don't deny that. Like,
Well, what I'm saying is just like the distinction that, like when you try to use computability theory to say that
mhm.
LLMs are only finite, I'm really struggling to understand how that exact same claim doesn't apply equally well to Terence Tao's brain.
Because he's running an algorithm that he has demonstrated, empirically, in fact, can go and access as much, external memory as he wants to. LLMs
Okay.
cannot do
All right.
that.
Oh, so I
What or
have one
they
more
they're
angle to throw at you. Yeah.
yeah,
Let me go to the next angle. Okay.
okay.
You take the LLM and you give it access not to full Python, but just to a single hash table, an arbitrarily, an infinitely growing
Mhm,
hash table. So
mhm,
as it's writing, it can just say, hey, remember this, or even
yep,
simpler, it doesn't even explicitly have to ask to remember. There's a special token it can output where it just says like revisit and then a token index. And then
yep,
next on the tape will be written what was in that previous token index, right? So now just because of that, we just smash through the context window limitation because
mhm,
it's now able to effectively look back on the tape if it wants to. So with that
yep.
simple modification, does that just completely make your argument irrelevant?
No, it just makes it some
See,
different architecture where in which it is Turing complete. So if you
okay,
can do that, so if you can modify an LLM to access, just some lookup store,
right.
Azure table or whatever, right? And take advantage of it, like actually take advantage of it algorithmically. Now you have a Turing machine.
I mean, you're calling it a different architecture, but like I could just go to the OpenAI API right now and just patch together something where I can explain to GPT. I can be like, hey, by the way, feel free to write look up open parentheses 55 if you want me to print the next token for you, if that's going to help your thing. So I can basically explain the game to GPT, and I can also implement
Mhm.
it, and I can do that all in like 15 minutes, right? So when you talk about a new architecture, it seems like a slight modification.
It's a slight modification to the architecture. Getting it to do something useful with that new capability is the problem. So I mean, sure, you
So
could go do that, and then when we try to get it to, for example, solve the pillar problem, it's going to fail.
right. So imagine I make that augmentation, and then
Okay.
now I'm going to ask it to factor a number, and I'm going to tell don't use Python. You have to use pencil and paper. But if you need to use this special lookup feature, you can. What is it going to do? It's
Mhm.
probably not even going to bother using the lookup feature, right?
In what sense? It's going to do
Like
what?
if
Give you
it's
a Python program that it asks you to go run on a Turing machine?
no, no, no. Imagine I say, hey, go factor, 100,579, right? Factor that number and don't use Python. You have to do it using quote unquote pencil and paper. And if you ever
Uh-huh.
use too much paper and you need to go revisit a previous token that you've outputted that's behind your context window, in the output
Right.
stream, it's more than a million tokens back or whatever, then here's a way to do it, right? It's the one augmentation I'm giving you. If I
Mhm.
give it that input, I would just expect it to take a stab at the factoring problem using a small amount of memory and not even bother to use this new capability I'm giving it.
I mean, that could be your expectation. Go try it. I mean,
No,
yeah,
I could try it, right?
my
But like,
expectation is, my expectation is, and again, I don't focus on factoring because factoring, I talk about things like, let's say, arbitrary multiplication of two integers. So I mean, today,
yeah,
if you give you make your modifications, okay, to O1 or whatever, okay, and it's not allowed to go run a piece of Python code on a Turing machine. Like, of course, now we have a Turing-Complete system, but it has this, hash table of yours, right? This little database that it can write to and look up or whatever. It's going to fail to do the multiplication. It's not going to fail because in principle it will always fail. It's going to fail because it wasn't trained to be able to utilize that store, right? And that's going to be where the challenge lies.
let's talk about that in a second. But like, this thing I'm trying to say now, right? This hypothetical I'm trying to set up. I mean, isn't this supposed to be like super useful? I mean, can you think of a specific problem where this new capability, now that it has this revisit function, like which specific problem is it now going to be able to do now that I've solved your whole issue, right? Your whole issue was it didn't have access to an infinite tape.
Mhm.
Well, now it does. So what can it do differently?
Are you asking what O1 specifically, or what a hypothetical thing that we train to utilize this new architecture could do?
Okay, so I think the claim you're making is like, if I'm just, let me summarize you. You're basically saying, okay, if you give GPT 4.0, not even O1, let's just say 4.0, you give that GPT this ability to revisit tokens, but
Mhm.
it's probably not going to get much value out of it because it didn't have it at training time. But if it had it at
Yeah, yeah,
training time and we change the architecture of training, suddenly you're going to unlock more intelligence, or eventually somebody will unlock
absolutely.
more intelligence. Okay, so that's basically your claim.
100%. Yes.
Okay. Okay, I mean, one thing that comes to mind for me is if you go to Terence Howell's office and you're like, "Hey, Terence, you know what? I'm going to give you here's like an extra stack of paper to work with beyond like the 5 white sheets of paper that are on your desk." Don't you think he's largely just going to be like, "I can do it in 5 pieces of paper for many problems."
Well, again, for many problems, absolutely. So
Okay,
there are many useful and interesting problems that can be solved with, let's just say, small or whatever amounts of Terrence, Terrence. What's his last name again?
Terence Dow. I hope I'm saying that right.
Terrence Tao. Okay, so whatever amount of memory he has plus 5 sheets of paper, there's tons and tons of problems. Okay, that system can solve under those constraints. There are more problems it can solve if it has 10 sheets of paper, and there are more problems it can solve if it had 100 sheets of paper. More problems it could solve if it had
Right.
a very large database. And here's the really cool thing: you don't have to retrain Terrence Tao because Terence Tao is
Right.
running an algorithm that can already utilize unbounded external memory.
I don't feel like I've ever used more than a megabyte of working memory to do anything in my life. What about you?
Oh, so working memory? I don't know. Probably not. Well, I mean, again, I'm
Okay.
not an expert on neuroscience. External memory, 100%, because I've written, so for example, I've written large bits of software that are larger than
Yeah.
that. And I have to go back and revisit this file and rewrite that one and coordinate it with some other file. And so there's this large expanding, mass of spaghetti code, right?
Okay.
That's much larger than what I can hold in my head.
Okay, and you agree that that's what you did is analogous to giving an LLM, let's say Python, right? And I think you've said, okay, yeah, if you give an LLM Python, then I can't make a confident claim on what kind of computations it can do, but because it wasn't really trained with running Python programs, it's probably just not going to be good at it, even if computability theory says that it could do it, right?
Yeah, that's right.
Okay.
So I mean, if you give an LLM, if you give LLM Python plus a machine that can run it on there, you give it a Turing machine. So you have an LLM and it has a Turing machine and it can run stuff on that Turing machine, then that's a Turing-complete system. The difficulty is in training it
Got it.
to take advantage of that. Yeah.
Okay. One
And I
interesting
think we will
route.
do that. So that will happen. People will get to the point where, and again, this is why I like to think about in terms of the algorithm space, right? So we will get to a point where we can efficiently search over a much larger space of algorithms, including algorithms, outside of FSA. So
Okay, so you can factor numbers using pencil and paper. You, Keith. What was your training process like? Did you really need a training process that was like Turing complete and use unbounded memory to train you how to factor numbers?
well, evolution's already baked into me the recursive mind. So I mean, like this is the important thing about Turing machines is that they're another way to think about them is that they're recursive, recursively enumerable, computations, right? And so that's already been baked into me by evolution. So I just had to learn how to adapt that inherent capability to factor numbers or to multiply them, as the case may be.
Okay, it seems like when we factor numbers as humans, there's fancier algorithms to do it, but let's say we just learn the algorithm of like try to divide by 2, try to divide by 3, try to divide by 5.
Mhm.
It's like, okay, we
Up to
learn
the
that
square root
algorithm.
of the number. Yeah.
Right, exactly. So we learn that algorithm and then we just do it. So like we didn't really need a feedback loop where like some long process played out and then like updated our weights. It's more like, okay, this is what factoring is. Here's an algorithm we could run. Let's run it. But it sounds like you're trying to
Mhm.
draw a distinction that like the reason LLMs are stumbling on factoring is because their training process didn't include a feedback loop after running Turing-complete programs, right? So it seems like there's a disconnect here.
Why is there a disconnect? Like it seems kind of obvious to me. Like if you don't, so again, human architecture already has baked into it this recursive, the recursive mind, this recursive capability to use external memory, right? What I'm saying is LLMs, they don't have that, and we don't know how to train them to have that capability yet. And so I don't see the disconnect. It's just like, yeah, they can't.
Okay, if I ask GPT-4 to factor a 6-digit number, I asked factor 301,701 without writing code. And this is GPT-4o. It said, the number 301,701 can be factored into its prime factors by manual steps. Check if it's divisible by small prime starting with 2. Since it is odd, it's not divisible by 2. So first of all, it's following the first step of the algorithm perfectly. And it kept going and going. And I think in this case, it actually got the answer right, which is rare, right? It gets it right like 1 out of 10 times. A lot of times it makes a mistake. But my question to you does this represent your claim about how, like, in this example, do you think that it could do a better job if something at its training time had a Turing complete feedback loop? Or like explain
Yeah.
what's needed to make this example go better.
Yeah. So it definitely, could do better if at a training time, um, it had access to a, so here it generates to you kind of a program. I mean, you asked it not to write code, like maybe, uh, like what's the right way to say this? How about we just say like it can generate code just to make it a bit more, because these steps or whatever that it's outlining might as well just be specified, in Python. So more like, let's say it can generate limited code. So code that's
Okay.
clearer than English, okay, but it's saying like
Right.
basically like it's putting out all the steps. It can do arithmetic in
Yeah,
sequence or
like what
something.
if you as a human get to punch in, you have a 4-function calculator, so when you need to do your trial division, you can just use your
Right.
calculator.
There you go. So some small set of operations, okay, that it can do. And so if during training time, right, we gave it a bunch of problems, here, factor these numbers, here's the right answer, okay, and we allowed it to generate code, go run the code on the Turing machine, okay, And then if it got the right answer back, it would remember, or that would be one of its samples in training, that this is the kind of code that gave the correct answer. Okay. I 100% believe that if it had that at training time, it would do better on this task. So it would generate code that was more reliable, more correct for larger numbers
Yeah. Wait,
of
but if we're talking
digits.
about writing code, that's a solved problem, right? I mean, the reason I said don't write code is because if I let it write code, it just writes the correct code to factor a number. So don't you think we
Well,
should
we
analyze
but
the problem without writing code?
sure, but I mean we're writing something like step. That's why I said like some limited steps. Like you can divide, you can do this. You can't just write a piece of Python code that says like call, lib dot,
Yeah. Okay.
numpy dot factor, right?
Oh, got it. This would be fascinating. Maybe I can ask it in real time here. So what if I go to GPT and I basically ask it like, don't write code except if you want to do division. How about that? Yeah, I'll give
Well,
it the
that
same
mean
question.
just tell it basic arithmetic operations.
Right,
Like the
right, right,
only
right.
code that you can do is basic arithmetic operations. Yeah.
Great.
And then
Okay.
see if it can give you a, working factoring piece of code. And of course, these kind of problems, right, are talked about in elementary school. So I'm sure it will find lots of examples online, right?
Yes. Here, I just told it factor 301701, but don't write code except you can use simple bits of code to do basic arithmetic.
Yeah, there you go.
All right. So
See
first
what
it's
it
trying to do
does.
trial division by 2. It hasn't even written any code yet. It's just starting to do trial division. It claims it's divisible by 3. I mean, it's interesting. It has the confidence to try to do math without writing code. So that's interesting. A lot of times it's overconfident about that kind of thing. Let's
Mhm.
see. So it said 3 is a factor. Let me see if I got that right. It did so far. So without writing any code, it just happens to be right. Like maybe this exact problem was somewhere in its data set. I'm going to tell it to please continue because it just factored it into 3 times 100,567. All right, so it's continuing. That's interesting. So it hasn't written any code yet, but like I guess I can't get it to write the right amount of code. But like,
Well, I mean, look, I'm just trying to make a very simple general point, which is if you want any machine to be better at any task, but let's say in this
yeah,
task, writing algorithmic steps to factor numbers, you need to give it that in its training data, right? And you need to give it that capability at training time.
so I feel like GPT 4.0 understands factoring as well as I personally understand factoring, right? If you want me to factor something, I'll try writing Python. If I can't, I'll take out a piece of paper and I'll try doing my own manual division. The only difference is that GPT 4.0 just can't actually do division reliably without a calculator. That's the only difference,
Mhm.
isn't it?
I mean, in a simple case, right, like factoring, where I mean, there's plenty of examples for it to have learned from on the internet, like how to factor, all kinds of factoring algorithms, Wikipedia's, written about it, all this kind of thing. Um, sure. I think what I'm saying is that if you wanted to be able to write general purpose code, right, or to be able to solve more general classes of coding problems, and in order to write Turing-Complete, programs, that needs to be baked in at training time. Like we have to actually give it that capability and examples so we can learn to optimize, for that skill.
Yeah, let's try to find an example of a specific problem where GPT 4.0 stumbles on it today. But if something in its training was somehow a more Turing complete feedback loop, then we should think that it'll do better. Because I think that's an interesting claim you're making. It doesn't make sense to me, but I would love to work through an example.
I mean, and none of the examples I've given, already are helpful, like arbitrary digit multiplication or, that's not helpful.
So the input is like, here are 2 numbers, just
Nth
multiply them
digit
out.
of pi,
Nth digit
nth
of pi.
digit of pi, is that not helpful?
So if you want an AI or a human to calculate the nth digit of pi, I think GPT will understand probably better than I do what algorithm you should run. So isn't it already trained correctly to get the nth digit of pi if it knows what algorithm to run to get it?
It depends on what we're talking about, like, 'cause, any, I feel like where we want to get to eventually is we're talking about super intelligences, right? And sort of general intelligences. And so any problems that are very well represented in the training data set are kind of sort of beside the point, right? Because then you could accuse it of being a stochastic parrot. Um, because it's just giving you basically it grabbed the code from
Right.
Wikipedia and gave it to you, like the article on, you know, how to calculate the integer to pi, right?
Yes, but just to frame the reason why I am drilling down into this, you're basically
Yeah, where are
saying
we
like,
trying to get to?
yeah, and I do think I do think this is productive because the larger point I'm trying to make is when I see human brains think, it really seems similar to me from a theory of computation perspective as when I see LLMs think. And the only difference I see is just one of degree. Like, oh, the LLM was thinking great, but then it messed up. Why did it mess up? I
Mhm.
don't know. But the type of thinking it's doing seems very similar. But then you're saying, no, it's so different because at training time, it didn't have the feedback of what would happen when an algorithm with an arbitrarily long tape runs. And if you're making that claim,
Yeah.
if you think that you see a difference in the fundamental nature of the thinking, I would like to just work through a good example to illustrate your point.
Well, so I mean, you've said so yourself, and everybody notices this, and OpenAI notices this, and which is that beyond a certain kind of point, they just start to break down. So they have this problem with long-term stability, right? So in other words, they're applying a set of rules in such a way that they break down, let's say more rapidly than we would like if you're trying to get to AGI, right? And that's really the point of algorithms, right? Is that they don't suffer from that. Like algorithms that are Turing machine algorithms, they have this ability to compute for an unbounded amount of time as required by the input problem to get the correct answer. And they're able to carry out this sort of precise, exactly correct chain of thought for as long as necessary. And I'm saying if you want to get LLMs to that same capability, we need to be training them with Turing computations at training time, training them to run those computations at training time.
I mean, I get your claim on like a high level, but I'm just curious, like
Okay.
what specific example it maps to, because I think it's interesting that we both kind of agree that it's an irrelevant claim on the example of factoring, right? Like it sounds like LLMs pretty much get factoring, except they suck at the
Well,
long multiplication.
I didn't claim it was so. First of all, like I haven't played around with, factoring, right? I mean, I don't know why we keep coming back to that. The one I usually use is arbitrary digit, multiplication. Like that's a very easy
Right.
one to
Yeah, like
understand. Like
long
why,
multiplication. Yeah.
and it doesn't work, and neither does the nth digit of pi. Like it fails to do that. All you have to do is just
Yeah.
give me an LLM that gives me the nth digit of pi, and I say, great, now you have a Turing-complete
Right.
system. I'm trying to get people to that point, and again,
Right.
with apologies, because I understand there are extreme risks to getting us to AGI. So I don't want to say like I don't respect that risk, but just as the intellectual exercise, right? I'm trying to get us to move towards that, and I'm suggesting this is how we do it.
So when I, as a human, do long multiplication, the amount of state that I'm holding in my head is pretty de minimis, right? It's like a few digits worth of state.
Yeah, because you're using a piece of paper. Me too. I'm not. The amount of state I'm holding in my head is like a couple digits because I'm writing it down on a
Right.
piece of paper that's unbounded.
Okay. So
You got to
aren't
have
I
that
a
unbounded read-write memory.
Okay, so if we look at how humans do long multiplication, aren't we just
Mhm.
always finite automata who can do multiplication up to like a million digits before we forget or make a mistake? Aren't we still finite automata?
So again, the controller of a Turing machine, which is what you should think of your brain as, is as a Turing machine controller, not a Turing machine, but a Turing machine controller is a
Sure.
finite state automata.
Right.
But it's
And
running an algorithm that can utilize unbounded read-write external memory.
don't you think that if you actually had a single human try to multiply a million digit number by a million digit number, they would be unlikely for them to get the correct answer? Like there's some limit where the human
Oh
kind of
yeah,
taps
well,
out. So it's not really like infinite.
no, I mean, and I don't disagree with that. I mean, sure, humans make mistakes. We're not. And by the way, this is also a common. No, I'm not saying you have this misconception, but there is a common misconception that Turing machines have to be exact and perfect. That's false, because you can always take a stochastic Turing machine and get it to whatever arbitrary degree of, precision you require by running it, multiple times, running verification procedures, blah, blah, blah. So could a human being multiply a million digit number? Like, I could, if you paid me enough. Like, if you wanted to pay me for me to prove that it could be done, it would take me a while, right? And that's kind of beside the point, because I'm talking about the algorithm class here,
Yeah.
right?
So
Yeah.
where I'm going with this is just that, like, when I see the average human try to multiply two huge numbers together and probably make a mistake, but still like make a good effort, to me, that seems very similar to an LLM trying to multiply two 4-digit numbers together and similarly making a mistake. Like, to me, there's just a difference of degree. I don't know how you solve it by training the LLMs using Turing-complete outputs. And I don't think that the humans who can successfully multiply long numbers, I don't think that they were trained using Turing-complete outputs. Like, I don't get what fix you're suggesting here.
I mean, first of all, this is an empirical question. Like, I mean, I'm making a suggestion here. I'm making a suggestion, and my suggestion is that, and actually this is just a kind of hack solution. I don't think this is the optimal, way to train. I don't think this is the optimal path to searching the space of Turing complete algorithms. I'm just saying that one way you could do it is, imagine you're doing the O1, kind of thing, right? Is you could allow it to run Python programs. If they get back the right answer, then it's learning chains of thought right now that kind of lead to accurate examples. It would now instead be learning the types of Python programs that lead to optimal solutions, right? And if you
But
did that at
doesn't it
training
already know that?
time, doesn't it already know Python
Doesn't it
programs that lead to?
doesn't it already know the type of Python programs that help you multiply?
Well, I'm going beyond like just simple, well documented problems. Like, whatever problems are in its training set, it's learning like the templates, right? Like, these kind of
Right.
templates give me good Python programs. And so then when I'm asked for something novel and I try to generalize to a problem that wasn't in my training set, now I can generate a new Python program, completely new,
Right.
to solve this new
So
problem.
I
And there's
get
a
what you're
good
saying, but
chance of it working.
you're going abstract again, right? You're going abstract again. I was hoping
No,
to
no,
find an
I'm
example that
trying to get
illustrates
very
your point.
practical.
Okay.
I,
But if you're getting
I thought
practical, why
I
can't
thought
we
we diverged. I've already given you specific examples. Like, you're saying now you were attacking my suggestion on how to build machines that are better at generating, Turing code, let's say, right?
Well, I wanted to find a specific example that contrasts, like, okay, humans really get this, but LLMs don't get it because it's too infinite for them, right? Like, they're using the wrong model of
Well,
computation. The controller is too finite, or whatever you want to say. Like, just illustrate your
well,
point
just
with an example.
go to the pillar problem.
Okay.
Like, the pillar, it failed to solve the pillar problem. That's only 5 steps. Like, you did
Right.
it. I can do it. Like, everybody in our Discord managed to do it. The LLM failed, and like, it failed tragically. Like, it fails in
Yes.
hilarious ways. And the reason why I was able to so easily, at the flick of like a tiny amount of my personal computation, throw it in a loop, is because I have this intuition about the problems that LLMs have. And they have the problem of carrying out precise computation that unfolds over time. Now, right now, even depth 5 confuses it. 2 years from now, maybe I have to give it a problem that has depth 10. What I'm trying to say is there will always be a relatively small depth that's going to confuse it until we start training it in ways that allow it to search the space of Turing-complete algorithms. Like,
Okay. So if I remember
does that
correctly,
make
yeah,
sense?
I think so. But let's do the example. If I remember correctly, you asked the LLM to do your pillar puzzle, and right off the bat, it started not really having a good plan for how to solve it. Right. So I feel like within the
Correct.
first couple sentences, you're like, oh, it's kind of BSing, like it doesn't really get the problem.
Yeah,
And
yeah,
then
yeah,
sure enough, like it screwed up. So
yeah.
does that really illustrate your point about it not being Turing complete, it not being able to utilize an infinite tape? To me, that just seems like, it went off half cocked and then it wasn't robust enough to fix itself, right? Isn't that kind of a different problem?
Well, look, I'm not running I'm not running a research organization that kind of like, tries to do a very careful experimentation. I mean, I think we're kind of, I don't know. I think maybe we've said what we can about this topic. Like, I'm just trying to say, if you want to train if you want to train machines that can generate Turing-complete behavior, whether they're doing it internally themselves or generating code that they're allowed to run on a Turing, a Turing machine themselves. Um, if you want it to do well at that, it needs to be trained to do that. Is really kind of the point I'm making, right? I mean, is
Yeah, it's
that
just
really
when
something
you
that
give
could be
this
denied?
example, right? See, you gave an example that's supposed to illustrate your point, but when we analyze the example, I just don't think that the analysis corresponds to your abstract point here. I think the analysis is just that like it started writing the wrong plan to solve the problem, and that's what screwed it up.
Yeah, I mean, I gave a bunch of examples, and it's sort of like the no true Scotsman problem. It's like you're like,
Okay.
well, arbitrary multiplication, sure, it can't do that, but neither can people, and it understands it. And factoring numbers, it understands as well. That doesn't count. This one doesn't count because like it clearly went wrong at the beginning. Like, okay, I mean, I cannot give you an example for now. So we'll just
Okay, okay, okay.
I
All
could
right.
try to
Well,
give you one
you've
later,
certainly been a
but
good sport. I'll give you that.
yeah, yeah, likewise, likewise.
Cool. All right, great. Zooming out a little bit, we're trying to talk about boundaries of what LLMs can't do yet. And my position is like, I don't think we know a boundary besides noticing that they shoot themselves in the foot at some point. Like sometimes they get off to a good start and then they mess up. So that's kind of my fuzzy boundary. I just call it robustness. But I want to ask you if you think you can see certain other boundaries. For instance, do you see a statistical boundary where LLMs can only do things that are statistically similar to their training data? What do you think about that claim?
Yeah, so I don't and do we really so are we focusing again LLM? Like is this my concept of an LLM, or is it maybe a more generalized kind of like, let's say, LLM system where the LLM is the brain, of a system, but it can do more things. It can run some
Yeah,
Python code, it can tweet
I think
things, it
it's
can read the internet.
I think it's most interesting to talk about like the best systems today, including all the types of clever hacks that people at AI
Mm.
labs might have thought of.
Okay, cool. So a more general, and let's just call those like I call those LLM systems, or somebody recently wanted to call them, large reasoning models, systems,
Right.
that sort of thing. So just whatever the state of the art is. And this is a point where I've seen, and by the way, after having, become aware of Doom debates and I watched, many of your episodes, enjoyed a lot of them. And a point that you bring up often is the church Turing thesis, right? And this is something that I absolutely agree with. So, inherently, I am a machine. I'm a bio machine. I'm running, or at least it's highly likely that I am running what we would call an algorithm, right? In
Right.
the same sense of a Turing machine. Like this is highly likely. There is a little loophole that we can talk about maybe later or not. Let's just say we are. So I'm a machine. I'm a bio machine. And if we're comparing myself to some alternative machine, like I don't personally think there is any limitation. So I believe that machines, um, constructed of non-biological material, running in silico, as long as they have a realization, they're embodied, right? They have like sufficient causal structure. Um, they can they can be creative, they can think, they can reason, they can have agency, they can have consciousness. I'm going to go out on a limb here, and I hope
Nice.
I don't piss off Chalmers or something, but I think they could be conscious. I agree with,
Yeah.
for example, Carl Friston, who says that um, consciousness is when you have a computation of sufficient temporal and counterfactual depth, right? Um, you have consciousness, right?
Okay. Yeah, fair enough. I don't have a strong opinion on consciousness. I usually just talk about the power of intelligence, regardless of how much consciousness comes along with it.
Oh, sure,
But
yeah,
let me ask about your 100-year view, because you're basically you're saying things that I agree with, right? Which is just like, hey, look, fundamentally, we're machines. Consciousness is physical, right? It sounds like
yeah.
basically you're a physical materialist, right? I mean, I am.
Hmm. Hmm.
Okay.
Yeah, these labels sometimes, like, I don't know. I think so. I think I'm definitely, I believe I'm a
Yeah.
materialist. Yeah, yeah.
Okay. Yeah. As opposed to like a dualist who believes in
Correct. No
ontologically
dualism.
fundamental mental entities.
No, none of that.
Okay. Yeah. Yeah. All right. Me neither. So In your 100-year view, if we just keep cranking on technology development and nobody cares too much about the risks and everybody just tries their hardest to keep making smarter and smarter and more powerful AIs, do you think within 100 years
Yeah.
we'll get to the level where the AIs are smarter than humans and more capable in every way? Or do you see humans likely holding on to some differentiating power?
Yeah, yeah, that's a good question. So, I think I do have to at least take a bit of time here to at least delineate, some different concepts. So I delineate between intelligence and general intelligence. So to me, intelligence is a skill at a particular problem, and general intelligence is the skill of finding skilled programs. Okay.
Okay.
So we can have artificial intelligence, we can have artificial super intelligence, we can have artificial general intelligence, and we can have or super, artificial general intelligence, right? We can have all those types of things. I think if we keep going the way that we're going, we already have we already have narrow super intelligences, right? We already have narrow super intelligences. Those exist today. I think we will continue to see um, more general but still narrow super intelligences, within 100 years. Like this is not stopping it. Whether or not we get to super artificial super general intelligence within 100 years, I think is more uncertain for me. I don't know.
Can you think of an example of something that you imagine regular old flesh and blood humans being able to do in 100 years that AIs can't do?
Well, I think that we will be able to construct and train AIs, and AIs will not be able to construct and train AIs. At
Okay,
least
so
not until
like,
we have until we have, artificial general intelligence at a super level, or at least like human level. That
and
will
when you try to
that will
imagine
not be
100
feasible.
years in the future, you just don't think that'll exist?
No, I'm just saying it's uncertain. So I mean, and this is always this problem of like meta probability, right? Because I don't the probability of that happening in my mind is highly uncertain. It's like a uniform distribution between
Yeah.
0 and 1. So I just don't know. I just don't know if this is going to
Right. So
happen or
like
not. I
very
think
rough
there are
ballpark, like 50-50.
Yeah, yeah. I mean, I think there are several probably critical innovations, particularly on the training side. Like I keep coming back to this issue of, training them, right? I think there are a few innovations we need to make in order to efficiently search the larger space of algorithms before we can get to artificial super, general intelligence.
So like Greg Brockman and Andre Karpathy are people whose jobs, if they can, do anti-aging and be alive in the year 2124, you think their jobs will be safe?
Well, I mean, like I said, it's just highly uncertain. So I don't know. I honestly I don't know.
Okay,
Um,
and your intuition here is when you think, because you mentioned the example of developing AI, and then you generalize it to like, well, like deeply understanding algorithms and being able to search the space about creatively search the space of algorithms could be
mhm,
like the
mhm.
last holdout human skill in your view.
Oh no, I don't think that's the last. I don't know that that's going to be the last holdout. I think there will probably the last holdout. I mean, if we're talking about just sort of replacing humans in terms of professions, jobs, that sort of thing, I think the last holdouts are more likely to be um, jobs like aesthetic type jobs where human beings, are able to produce content that other human beings really like. Like I think those may remain things that are, hard for AI just because they're different from us. And so it's almost like,
Yeah.
can things that are very different from us produce things that really resonate with us? Nah, I don't know.
Really? It's interesting that you bring up that example because that seems like the type of example where you get a lot of input output training data and you can really just learn regression on that, can't you? I mean, aren't they already making very beautiful artworks?
Well, no, not really. I mean, if you go look at the things that like Dolly and whatever generate, at least for me personally, I get bored of them like quite quickly. It's kind of like after I've seen, 5 or 6 examples, kind of like, whatever. Like, it just doesn't really,
Yeah.
there's just some fire that kind of misses. It's really apparent in writing. So when you read material that's generated by, say, GPT right now, it's, it's coherent. It makes sense. It just doesn't have that kind of like panache and that.
And you think it's plausible that 100 years from now, it's still going to lack panache?
I think it's plausible. At least not. Let me put it this way. I think it'll be able to generate um, tons of content that has categories that really resonate with people. I think there will be some that escape its capability, and it'll have more to do not so much with what it'll have to do with is that whatever factors the human being is aesthetically appreciating are just kind of very difficult to deduce from the training data. There's some stuff in our brain that we all share that's not apparent in the training data or easily deducible from it.
Okay, I mean, I'm tempted to move on, but like when you say not easily deducible from it, I mean, doesn't it have the full specification of the output? So whatever there is to be deduced, it's supervised learning. Like it has the entire output, it has the signal. Can't it just learn it?
No, because it's missing some stuff that's in our head.
Okay.
So we have this shared. So you and I have this shared, genetic endowment, right? I mean, we have some stuff in our brains that we have in common. Like, and I think that it's possible that it's not easily deduced from
Okay.
the training data. If there's sufficient training data, this is kind of the whole argument of the paucity of data, missing data type arguments, right? Which is if the space is highly dimensional, right? You can just be in a situation where it's really difficult, if not impossible, to get enough data to completely, scope out the manifold in that dimension, right? Yeah.
Okay. Fair enough. Let's compare our views on agency, because I want to ask if you think agency might be a boundary between what AIs can do versus what humans can do. Maybe
Okay.
humans can do more because humans have more agency. That seems like a pretty popular claim that people make. I mean, it doesn't seem like a good claim. It seems like a pretty easily dismissible claim, but it's pretty popular. So my question to
Hmm.
you is, do you think AIs are really far from having agency? Is that a robust separator? What do you think?
No, I'm not resonating. Not resonating with that one. And I know. And so my co-host talks a lot about agency. To me, agency is something. And again, okay, look, disclaimer: I am not an expert on agency from a philosophical perspective. Okay, so I'm not even sure, what I'm about to say is or is not compatible or easily dismissed or whatever. But my concept of agency is just if I have a machine, okay, that's in an environment and it's sensing that environment and performing a computation, and then it can perform actions in that same environment, that's an agent. And I don't see any reason why I couldn't have a machine that could do that. I mean, I can build an Android, right, that has a machine brain and participates in the environment.
Mhm.
So I'm probably missing something deeper, to this argument, and maybe
I
I
don't
don't
think you are.
have an opinion.
I think you're right.
Oh, okay. Okay. Well,
I
yeah, it
just
could be. I
wanted to
mean,
test. I just thought this could be like if you were one of the people who were like AIs can't have agency, then I could disagree with you. But it sounds like we agree.
well, I want to give credit to philosophers. I'm sure. I mean, philosophy is a very sophisticated field, so I don't want to downplay this as a potential issue. I'm just saying I don't see it, myself right now.
Okay. All right. Let's talk about intelligence versus optimization power. So
Yeah.
if I were to just
Yeah.
define intelligence, I always turn to the optimization power definition because even if I'm not going to win the semantic slap fight about how a word should be defined, I can tell you that optimization power is what I'm scared of. I think the thing that's
Oh,
going
okay.
to end the
Okay.
world is going to measure higher than humans in optimization power. I don't think we can survive building something with high optimization power. So when I talk about AIs becoming super intelligent, the conversation I want to have is the high optimization power conversation. And for those of you who don't know the definition, basically optimization power means that you can squeeze the future of the universe or the future of a game board in some game into a narrow target in state space. So like a chess game, I can give you any chess position. And if you're really good at chess, you can find a sequence of actions that'll always map the chessboard toward a winning state for you. That's an example of optimization. You can do optimization on the level of the universe. If I say, find a way to attack this country and make sure you win the war, well, let's say that your resources, you don't necessarily get an advantage in resources, but you just have the best clever plan, and you optimize the universe into the end state that you want, and you do so better than the enemy can do it for you, right? So you win the optimization battle. So what do you think of optimization power as a mental model? Is it a useful mental model?
Yeah, so and I'm glad you explained that because I think optimization is one aspect of intelligence. I think there's more to intelligence than just optimization. So, and again, I'm thinking about these things kind of algorithmically, right? So to me, a sorting algorithm is an intelligent algorithm. It doesn't have anything to do with optimization. I can frame it into like an objective function or whatever, but that's just a bolt on.
Can I push back on that a little bit? I mean,
Sure.
so the input can be a wide range of unsorted lists. And then the output for a given set of numbers, there's only one version of the sorted list. So you are actually
Mhm.
seeing an optimization dynamic happening there.
And I'm saying you're not. So, for example, there's nothing more optimal about sorting from A to Z than there is Z to A, right? This is just some, and I really, this is only a small quibble here because I don't. So intelligence, I just think is a broader category than optimization. However, like optimization is definitely something that intelligence enables.
Mhm.
Okay, so I don't. Is that okay if we?
Yeah. So, and neither of us are interested in just playing semantics. So let me tell you
Right.
where I'm going with it, which is just, I think optimization power is the most interesting question when we talk about AI's reasoning. Like, instead of looking at every AI and being like, I don't feel like that's reasoning, I feel like that's reasoning, I think it's useful to step back and look at the input output and being like, wait a minute, is it mapping a wide range of inputs to a narrow range of outputs that meet these optimization criteria? If it's somehow doing that, then whatever's in that black box, I'm tempted to credit it with being an intelligent reasoner, because how did it achieve this input output? That is like hard for humans, right? I tend to take that
Yeah,
perspective
yeah.
of things.
Yeah, and so I think that's fine. I think I typically think to me I think more in terms of like search, right? Like I've already talked about earlier, which is that if I'm able to efficiently search the space of all possible algorithms, uh, you can call that an optimization, and that's fine. I just think about it a little like slightly differently. I just think about it more in terms of search and looking because a lot of things a lot of optimizations are more like, here's a structure and here's a bunch of parameters, right? How can I tweak these to make it, perform better in some certain way? Which I just look at a little bit differently as let me search a space of a whole bunch of, discrete possibilities, for example, and find one that performs the problem. But it's the same thing. Like we're
Right,
talking about the
exactly.
same
Yeah.
thing. And
So
that's the scary
creativity,
part,
yeah.
right?
Creativity
Yeah.
and optimization and search,
Right.
I agree. Like, they're all getting at the same thing, which is just like, there's a lot of possibilities, but somehow you got to a good
Yeah.
one. Yeah, exactly.
Yeah,
So
yeah, and I really like that. I like your framing of that because it's a powerful way I think of thinking about the power of intelligence. Right? Is that in this very large space of things, you get to one that's really good. It works. Maybe it's not
yeah,
the
exactly.
best of all, but it's like really good. So I think what I want to ask you about though here, because I've seen you talk about this a lot, is I get the feeling that maybe you believe intelligence alone is sort of sufficient. It's kind of like if I had a little soccer ball thing here that was just super intelligent, and as long as it just had like one or two little sensors, like maybe just an Ethernet port or something, and I plugged it in there, that were just all like immediately doomed. And this is the part that I have a problem accepting because I think that intelligence is one thing, but capability, power, the ability to execute whatever you're thinking in your mind requires other things. It requires,
Yeah.
infrastructure, physical things, manufacturing facilities, whatever else. So
Right.
where's the disconnect there?
Yeah, I'm glad you brought that up, because that is a load-bearing crux of the doomer worldview. The idea that, like, yes, intelligence is all you need, because intelligence can pretty quickly finagle everything else that it needs. So imagine you just have the AI sitting in the sphere in some data center. even with an air gap, whatever, pretty quickly it can start escaping, right? Like if you can just convince some human in the data center to escalate its privileges or find like a 0-day vulnerability, are you following the part of the story where it hacks into a bunch of other computer chips?
Yeah, so I think I get in on, and I've heard lots of kind of tales of this, right? And I think these are all imagined possibilities. I think what they don't account for is that there is a super intelligence, which is the conglomeration of 8 billion or whatever we're up to now, people existing on the earth with all our weapons, all our might, right? So if we have kind of mind and might, it's starting at a massive kind of disadvantage. And I think that it's always the doomer position. Doesn't matter how much might people have. It doesn't matter that on many dimensions, corporations are super intelligences, that there's a collective intelligence of humanity, blah, 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 blah. None of that matters. We're just
Okay.
going to imagine a little narrow path by which it destroys everything. And I think
Okay.
that's kind of
Yeah.
the weakest point, of
Does
doomerism, right?
it sounds like
Or
I may
that's the
have
weakest point of
adequate. Yeah.
Foom, not doom in general. Yeah.
It sounds like you made a previous point that maybe you think my response was adequate, dude. Because I think your original point was, doesn't it need more actuators than just living inside a computer chip? I feel like I started convincing you that I was right about that. So then you moved on to another claim about like, okay, but how's it going to take on human society?
Oh, okay. I didn't mean so I didn't mean the actuator thing, right? I'm just talking
Okay.
about in general might, right? So
Okay. Okay.
you have human beings, which are super intelligence, like our collective super intelligence, with tons and tons of might. And then you have this new little ball that shows up
Yes.
with an Ethernet port that has like zero might, but
Yeah.
really great intelligence. Okay. And
Okay.
I'm saying like it's not clear to me that like any nerd in high school can tell you that there's more to winning a fight than intelligence, right?
Yes. So first of all, I think taking over a billion computer chips is low hanging fruit. What do you think about that claim?
Okay, sure. I'll grant that.
Okay. So once you have a billion computer chips and there's some coordination among them, right? Like it's your botnet, you're the super intelligence.
Mhm.
From there, it seems like a pretty easy jump to having a bunch of human employees because there's a lot of way to turn genius and computation power into humans doing what you say. I mean, if you need money, go make money by predicting the stock market, right? Like arbitraging the stock market using your intelligence. Okay. So now you have money, so you can pay some people, you can make shell corporations, you can pretend to be
Yeah, yeah.
people's girlfriend, you can ransomware them. So
All right.
are you following the jump from like being a billion strong botnet to having a bunch of people on your payroll and who are loyal to you?
Yeah, yeah. So no. So this is and I've heard these stories before, and I've heard like the many variations of it. Diamond nanobots, like all kinds of things.
Yeah.
I just wanted to know, and I didn't really want to. I don't want to try and dive into those in great detail, at least not in this conversation. But I just want to understand, like from your perspective, that's done, sealed, no problem whatsoever. Like it's like, in other words, you see that as a very strong, high probability argument that if I just have a ball that's super intelligent and I plug it into an Ethernet port, that we're toast. It's like
Yeah.
99.99% chance that we're toast, right?
Um, if it really is super intelligent and it has some utility function that it's trying to optimize, that's not the human utility function. Yeah, and I won't even say you have to plug it into the Ethernet port. I think we're
Okay.
just
Okay. Yeah, yeah. So I think maybe in some future point it'd be fun to have a conversation about that. I just wanted to make sure that is the position, right? Which is
yeah,
and
because
then, and of course
one
that's more a scenario where like a ball from another planet shows up because it's already developed its super intelligence. It didn't have to go through any
right, yeah.
any child stages or anything like that. But once it's here, like once there's a super intelligent ball, if it has sufficient super intelligence, and maybe not even an Ethernet port, but just a radiator or something, that it's kind of
Right.
like
Yeah. Exactly.
we're done for. Yeah.
Yeah, so the problem is the way I like to phrase it is physical reality has poor virtualization. So the idea of like, okay, it's sitting in a ball, that ball is causally connected to the rest of the universe. Like there's a lot of causal links that humans don't understand well or that they don't understand the
Mhm.
implications of, right? Like it can send a radio signal. I mean, we see these kind of side channel attacks all the time, right?
Yeah, 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 and I understand. I kind of just I wanted to make sure for sort of my future thought that is a scenario that you believe
Yeah.
is, very like highly certain that it's possible there's a ball that's sufficiently intelligent and maybe just has some ability to observe and radiate light, or whatever it is.
Right.
And yeah,
Yeah, I mean, there's a couple intuition pumps, right? I mean, imagine chimps seeing like the first humans, right? These hairless apes, and being like, they're going to be able to wipe out like 1,000-mile circle with these bombs that they're going to drop. And the chimp is like, what? You're telling me that like you can just a hairless ape is going to somehow go from being a hairless ape swinging in the tree branches to doing this magic, right? Like making these rockets go to space. Like that seems like a pretty tall order here. Like it seems like you're going crazy. And it's like, no, no, no. Like the key was that the universe just has these paths. Like the universe is very hackable and it has poor virtualization and like, it's low entropy. Like we just live in a universe where you can pull that off. And the only limiting factor is knowing how to do it, right? The smarts to do it.
right. Okay. Yep. So I mean, even if that's taken for granted, then we have to get to that point, right? So we have to build the AGI because initially it's not going to be a ball with a bunch of hackable hacked universe capabilities. It's going to be a big data center.
Right.
Starting. Yeah. Okay.
Yeah. I mean, from my perspective as a doomer, we're just getting closer and closer to the game over condition, which I also like to refer to as like we're about to brick the universe, right? Like sometimes you're playing with your iPhone and the iPhone gets bricked, but the ace in the hole is you can restart the iPhone, but there's just no equivalent thing that you can do with the physical universe.
Right. Right. Now, I mean, in sort of your doomer, your perspective, like your worldview, is it more likely that we're going to get to a super intelligence that does that kind of thing, or that we're just going to destroy ourselves because we build, autonomous drones and somebody uses them to start a nuclear drone war?
I think so. I think nuclear extinction is very real. It's like a 1% a year threat. And I'm a pretty big nuclear doomer. I'm like, there's a 1% a year
Okay.
extinction threat. Like, that's very scary. But I think my P doom from AI is like 50% by 2040, which is that ranks it above nuclear doom in my doom ordering. So I just think we
But
keep
is
getting
that is that
closer.
from is that from
Right.
AI because from an AI decides to do this, or we misuse AI and pretty much destroy ourselves with AI?
I think the distinction is smaller than people realize. Like, I don't, it's hard for me to predict whether you can trace it back to a trigger of like one particular company that pushed one particular start button. I think it's just better to analyze it as like these uncontrollable agents keep existing, keep getting closer to this threshold where they're uncontrollable permanently. And then there's some triggering event. The triggering event could just be some random research lab researching it, running the next prototype, and then losing control. Or it could be somebody intentionally having a secure system where they have to like lift up the glass and press the button, and then that's what kills us, right? Like the triggering mechanism isn't as interesting to me.
Okay, the triggering mechanism's not as interesting. All right. I mean, to me, it's interesting because it goes a lot towards prevention, right? Like if you're
Yeah.
trying to prevent the scenarios and you're gaming out, triggering mechanisms matter a lot, right? Because they especially matter if you believe we're kind of on this tightrope, right? That we need to develop super intelligence to, and I say this roughly, for humanity in air quotes to continue like for a long time. Then you would care about what the triggering mechanisms are because you want to try and press
Yes.
the development of AI. Like, for example, something I really believe in is perhaps a viable path forward is, let's just suppose, for the sake of argument, that we could enforce worldwide that we could only research narrow intelligences and they had to be, very narrow and not even getting close to general capabilities to AGI. Um, like, would that be a viable path forward to avoid this type of triggering event that you're talking about?
In principle, it could be, but I'll make an analogy to nukes. So, I mean, there is kind of a natural analogy, which is like useful nuclear power generation compared to a nuclear explosion.
Hmm.
And in that particular case, there's a single scalar that can tell you which side you're on, right? If the reaction is going super critical, right, where it's each neutron is creating two neutrons and then you just spend your entire fuel and release a ton of energy, then that's bad. But if each neutron is only creating exactly one more neutron, then you can just keep generating power off it at a good rate, right? And you can even damp it down to zero when you're done. So you have a single scalar making the distinction when you're generating useful nuclear power. When you're generating useful AI value, unfortunately, that separator, right, the linear separator, whatever it is, it's like a very complex shape that nobody knows, right? So we're just exploring the space. We're like, hey, look, I made it more powerful. It's like, are you about to hit uncontrollability? Like, I don't know. It's just more powerful. It's more useful.
No, I mean, it's an it's an interesting question. This is why, like, for example, in nuclear world, right? It's about the purity, the levels at which you're allowed to refine, nuclear material, because weapons require higher grade, material
Right.
than energy, right? But it's interesting because I'm not convinced. I think there are ways that we could define what types of intelligences we allow, potentially. I'm not saying for sure, but I think it's possible we could define that. It's kind of like maybe we could put in barriers that say, like, and again, imagining you can enforce this, like that's part of the hard problem too, is getting everybody on the same
Right.
page and they're not being malicious actors and
Hmm.
bad actors, whatever else. But just suppose you could say, okay, look, you can never have a feedback loop between like the output of a super intelligence and its own code. It has to be kind of firewalled, and you're not, and there's a whole bunch of other restrictions on how the output is used. And, maybe we can identify certain types of computations that are not allowed to take place in there. It would be interesting to see if kind of the intelligence science community could sort out um, safeguards. It would be interesting to see if they could sort out safeguards that the doomer community looked at and said, okay, yeah, if we could enforce all these things, then P-doom of this kind would go down to some smaller number.
Yeah. I
Is there
mean, if
even
we could
any
just say
work being
this type,
done? Like,
yeah, work being done. I mean, a lot of people have that idea, right? Of like, let's stick to narrow AI. And I think maybe AlphaFold and AlphaProteo, those might be the biggest success cases of like, look, it doesn't look like AlphaFold is going to take over the world. It looks like it's useful narrow AI. And that's great. But the problem is, if you really want to get good at protein folding, it's always going to help if you can bring to bear some general intelligence, right? If you can step back and you're like, what other factor might influence this protein folding, right? And you can start
yeah, but
modeling the
we have
larger
to
universe.
disallow that, right? Like that's kind of my,
Right.
if we
You
could.
have to
So
disallow
I
that.
guess the question is, yeah.
Well, the problem is, even if you want to disallow it, if you just train one of these narrow reasoners to get better and better, they might stumble upon general intelligence, which is what happened to humanity. Like no other animals ever stumbled on this, but when evolution was just training us, like, listen, you're a narrow optimizer. You're just trying to optimize genetic fitness, okay? But then suddenly,
Mhm.
general intelligence comes online and we can go to the moon if we want to.
Yeah, yeah, but we have the advantage of already knowing about general intelligence, and so I think we
Right.
understand a lot about computation, and even though these are difficult, they're not necessarily intelligible. They are white box in the sense that we can examine, what's happening. We have total control over the parameters and whatnot. So I think we may have a better chance than evolution of not accidentally stumbling on general intelligence.
That's fair. Um, Real quick, as we get to the wrap up here, what are your thoughts on alignment? Do you think that we know how to make AGI do what we want as its intelligence increases?
So if we stay away from general intelligence, yes, I think we do. I think we know. I think in fact, like this is probably like a bigger topic. We should probably talk again one day. But
Sure.
I have a lot of problems with like the orthogonality thesis. I don't think it's really, I think it relies on kind of counting arguments that are flawed, like inherently with
Ah,
with
okay, that argument. Okay.
yeah, yeah, yeah. So I mean, and I don't want to get into that rabbit hole, but I'll just say I think if we stick to narrow intelligences, I think we do have a good handle on how to keep things aligned. If we stray into general intelligence, um, I think we have a problem. Um, especially if it's a
So,
general intelligence that's allowed to modify itself, right? Like basically, as soon as you have a general intelligence that's allowed to modify itself, um, you set up evolution. You set up an evolutionary system, and
right.
no, like you can't ultimately control that.
Does that mean that you believe in instrumental convergence?
So no, I don't believe in, because I don't accept the premise that there is such a thing. I don't accept the premise that a superintelligence will have, quote, a final goal. Okay. And I also don't think a superintelligence will allow itself to, I don't think a superintelligence will ever have a really stupid goal. I just don't,
Mhm.
or at least a general superintelligence. Again, narrow superintelligence, absolutely. You can have a narrow superintelligence, but a general superintelligence, I think there are inherently topologies within the space of minds that are totally ignored or unknown to the doomer community, and that the counting arguments are flawed and, everything else, and that a superintelligence alone, if it's not a general intelligence, cannot take over the world.
Okay. How about let's go down the rabbit hole a little bit of
Okay.
orthogonality thesis and instrumental convergence, and then we wrap up. How does that sound?
Sure. Sounds good.
Awesome. Okay. So on instrumental convergence, do you think that if somebody went off and built a general intelligence utility maximizer with some utility function, maybe a smart utility function, maybe a stupid utility function, but like if that exists, then would that agent converge to like seeking power and, instrumental convergence? What do you think?
I think that there are goals and minds that um, would seek power, that would do those kinds of things. I don't think it's clear at all that that's the majority of the landscape. I think I've seen no valid argument, okay, that in this vast space of, minds, that it's almost surely the case that you're going to have an artificial super general intelligence that is power seeking and atomizing and sort of turns out, like, I think the argument for that is just, not solid at all. And in
Okay.
fact, like the latest statement that I saw on, I think I visited Less Wrong, sometime recently, and read the statement for the orthogonality thesis. I know you were asking me about the convergence, instrumental convergence. I think those two are actually like very closely related, because instrumental convergence, right? Or sorry, instrumental convergence assumes like a certain kind of distribution on the possible minds, which requires orthogonality in order for like that counting argument to kind of exist. And I mean, the orthogonality thesis was, had this sort of very strange phrasing in there about like, there's no difficulty in the existence of these things, and like mere existence alone is insufficient for the claim that it's likely,
Mhm.
right? Like the
Yeah, it just
possibility of existence. Yeah.
let me try to summarize what I'm hearing here about instrumental convergence. You're basically saying when somebody builds if and when somebody builds an agent which is usefully optimizing towards some utility function, right? Like powerfully optimizing towards some utility function, the simplified model of utility maximization, a model that would have you predict that it will instrumentally converge to power seeking, that model just won't realistically apply to the actual AI that somebody would ever build.
I'm saying that I see no evidence or argument that the chance it will apply is very high.
Mhm. Okay. So you basically think as we navigate AI space, right, as researchers keep coming up with new AIs, keep making tweaks, we're just never going to get into that part of AI space where you have something that's accurately modeled as a utility maximizer or falls into an attractor state, becoming more and more of a utility maximizer, and then going to
Yeah.
instrumental convergence. You just don't think the slippery slope is going to lead there. You just think researchers are going to only produce other types of AIs.
Well, I mean, you keep trying to make this a binary choice. So I think what I'm saying is I don't think there's a 99.9% chance that we're going to end up in the utility maximizer that destroys the world. I think the space is a lot more constrained than that, and that there's a very good chance we'll wind up with, um, again, if they're narrow intelligences, it's a very good chance we're going to wind up with well-controlled ones. Okay, if they're general intelligences, artificial super general intelligences, I think there's a very good chance we won't control them. But I think what they will do will be radically different than what Udikowski or you or anybody else has imagined. And so to think that your imagination that they're going to atomize everything is just, you're not even remotely capable of predicting what they're going to do at that point.
So you
We
do
will have
imagine a
lost
possible,
control, though.
yeah,
We will have lost
right. That's
control. It's
interesting.
not up
So,
to us at that point.
so when you think about the most plausible scenarios where most of your probability mass is going to, you're basically
Mhm.
thinking of one scenario where the AIs have gone generally intelligent, they've gone uncontrollable, but you wouldn't say that they're showing instrumental convergence, right? That's basically the scenario you're imagining.
Correct. I think they're gonna show a lot greater variety than what we imagine.
In that scenario, are they refusing to be turned off? Just to clarify, like there's no off button in that scenario?
Well, at that point, the only again, I don't want to imagine, what they're gonna do, right? Some of them may just decide to turn themselves off, for
Right.
reasons that I
Imagine they're
can't
trying to do
imagine.
something, right? They've got a plan, right? They've got like a plan that's going to last 6 more months. And then some
Mhm.
random human wants to come and like fight them or turn them off. In the scenario you're imagining, they're just going to resist that, right?
Yeah.
Okay, well, what if the human is a state actor and sends quite a lot of weapons at them? Are they going to invest resources in their defense?
I mean, and now we're getting into sort of slipperier slope, right? Because it's entirely possible that they may discover morality, right? They may discover concepts that would prevent them from doing that. They may, for example, they could decide, you know what, there's these other life forms here. They're really annoying, but hey, just like the United States decided to end slavery, we're just going to go somewhere else. And there's just no need to stay here
Mm,
because these idiots like can't even get off this planet, and there's a lot more convenient stuff elsewhere. So like Jupiter is actually a lot more promising for whatever we're trying to achieve, and they go over there.
okay. Um, what about the scenario where they have some goals that involve doing something on Earth? It sounds like if you're willing to acknowledge that that's a plausible scenario, and you're telling me that they're going to be like hard to turn off, they're not going to be very open to the idea of people turning them off at any
Yeah.
given time. If that's not their plan, it just sounds like I might be able to lead you down the slippery slope to be like, okay, they're going to be quite dangerous and quite seizing of power and resources. No,
Well, I think where I would agree is it will not be up to us.
okay,
So what I would agree with is that it's entirely possible we could build artificially general super intelligent entities at which point we cannot control them and it won't be up to us what they decide to do. So that's absolutely a realistic scenario. Where I depart is that automatically implies they're going to atomize the earth. I think that's where the arguments are not strong enough. But even this scenario, right, of creating an ASGI that we don't have control over is scary by itself, right? Because it may just decide,
yeah,
hey, these humans make really great pets. Like, let's make them pets. I mean,
yep, yep,
why not,
okay,
right?
all right.
Or like, how about this? Like, I know you're probably a fan of Werner Vinge, right? Or
You
you've
know, I
read,
never got around to reading his books, but it's on my short list of what
oh
I should read.
goodness,
I know.
please, just like at least read the preface of Fire Upon the Deep.
Yeah, yeah, yeah. That's the
You'll
one I've been most
you'll
strongly recommended. Yeah.
you'll love it. So just read the preface of it. And
Okay.
in there, for example, there's all kinds of super intelligent minds that sort of decide to do different things. And this particularly malicious one, I don't want to spoil too much, but basically it decides to use human beings as a resource. I mean, not to atomize them, but as a robot. And it has the capability of essentially just reprogramming, the human mind to go and do the things that it wants, right? And act as a self-replicating, automaton to manufacture things and also try to convince the rest of the galaxy to join and, stuff like that. So,
Mhm. Great. All right. And finally, so on orthogonality, I kind of know where you're going. Like, hey, it doesn't have to be amoral. Maybe it will discover morality, right? Is that like roughly how you think about the orthogonality thesis? And maybe just remind people what is the orthogonality thesis?
yeah, so the orthogonality thesis, at least as, Bostrom presented it, right, is that you can have any arbitrary degree of intelligence, okay, combined with any arbitrary goal. So it's just, goals and intelligence are orthogonal. You can have
Yeah,
any combination of that, right?
which I
Um,
agree with.
Yeah, and I don't. So I don't agree, at least especially if you're talking about, again, general intelligence. So I think there's a
He,
again, this word
he,
intelligence kind of like has a little bit of an ambiguity, right? Are we talking about general intelligence or narrow intelligence? So I would agree you can have any degree of narrow intelligence focused on any goal, right? We're doing that today.
okay.
Where I disagree is that you can have any degree of general intelligence focused on a goal. I think there's a manifold there. There's a landscape. So in other words, the designs. If you take the design space of super general intelligent minds, okay, the manifold of mind of that kind cross goal is a very small dimensional, subset of that. Okay. And so you
Okay.
can't just make a counting argument and say, like, therefore almost all generally intelligent minds are bad because they've got these like stupid goals of, building paper clips or whatever.
Let me just clarify your claim. So when you quoted what the orthogonality thesis is,
Mhm.
I would say you quoted a pretty weak version of it. I mean, I don't even know what's the official version, what's weak versus wrong, but I consider it a weak version because you just quoted it as saying that you can have an arbitrarily intelligent mind that can have an arbitrary morality or an arbitrary set of values. So it seems to me weak to just say can, because can is just in the sense of like, in the space of possible algorithms, can it exist? So are you pushing back that it can't exist even in the total space of theoretically possible algorithms?
Well, so I looked it up here. Let's just read, okay, the strong form of the orthogonality thesis from Less Wrong, which I'm assuming is our Bible for this purpose,
Correct.
right? Like our one true leader. Okay. So it says there's no extra difficulty or complication in the existence of an intelligent agent that pursues a goal above and beyond the computational tractability of that goal. Okay. And first of all, like I can't, it's hard to even make sense of what extra difficulty or complication in the
Yeah. So let's
existence
try
means.
weakening
Like
it. Let's try a
that's really
weaker
kind of
version, right?
unintelligible, right?
Let's just say
No, no,
exists in
no, no,
algorithm
no.
space. Okay.
Let's stick with this thing here, right?
Okay.
Like so, because this really importantly summarizes my objection, okay, which is there's no extra difficulty, okay, in the existence. What this means to me, right, is that we have a design space of minds, and again, I'm going to have to substitute in here intelligent to generally intelligent, okay? So we had this design space of generally intelligent minds. I think what no extra difficulty and complication, what that means is this is uniformly distributed, right? That they're all kind of
Yes.
equally likely. And that's what I disagree with. I don't think
Okay.
the distribution of design space is uniform. I think it's highly structured along a manifold in which the vast majority of general intelligences are not mindlessly pursuing some stupid, make paper clips goal. Is my point.
Yes. So I understand that you have objections to a somewhat strong form, which may be the default form of the orthogonality thesis. So I just wanted to clarify, what do you think about the weak form, where I say,
Okay, what's
if
that?
I can navigate the entire space of possible algorithms, will I find algorithms in the entire Cartesian product of intelligence levels and values?
General intelligence or narrow intelligence?
General intelligence.
No, no.
So you disagree with the weak form of the orthogonality. So for example, like you don't think that there is an algorithm in the space of all possible algorithms which loves death and murder, but is also like extremely intelligent. So you think that's like an unlikely
Well,
algorithm that could ever exist.
so I'm sure that again, general intelligent, right? So we're talking about is there somewhere in the space of all possible algorithms a generally intelligent homicidal, algorithm? Yes, that
Okay.
exists. There is not in the space of generally intelligent algorithms a paperclip maximizer.
Mhm. In the space of so what's the bottleneck? Because that's it seems like there definitely is an algorithm space. No, why is that fundamentally impossible?
Well, I'm saying there's a manifold in there. I'm saying there's a relationship between goals and general intelligence. That, for example, the hypothetical paper maximizer is just almost by definition, not generally intelligent, because a generally intelligent super intelligence that decides to make, paper clips is just stupid, like by definition. And so this is my
Okay,
point,
I
is
see.
that I don't buy the orthogonality thesis at all. I think there's a manifold structure in there, okay, in
Okay,
which there's relationships between goals and super general intelligence.
let me just repeat back to you. Tell me if I'm getting this right. The whole concept of caring to make the universe into paperclips is not intelligent. Therefore, you can't have every possible goal with every possible intelligence levels because some goals are not intelligent.
Correct.
Okay. So that just seems like you can't really entertain the orthogonality thesis because we have a disagreement about the definitions of the words used in the statement of the thesis, right?
Well, what I'm saying is that, first of all, at least the orthogonality thesis that's currently, as of right now, up on Less Wrong is unintelligible. Okay, he's done a poor job of explaining in English whatever it is he's trying to get across, because the phrase extra difficulty or complication in existence is not
Sure, sure, sure.
intelligible. Okay,
Okay, yeah,
so
and
A, I'm saying it's unintelligible. B, I'm saying if we try to make it intelligible, what I'm saying is that in the distribution of minds, it's not uniformly distributed. And so
right.
therefore, there's a manifold structure of some kind in there,
Yeah, yeah, yeah.
which implies it's not orthogonal. There's a function.
Okay, and you see why I'm asking about the weaker form because we're not even agreeing on the weaker form, right? So why jump to the stronger form? Let's keep talking about the weaker form.
Okay. I mean, so in the weaker form, well, if we take, here's my hypothesis, right, is that there's not orthogonality because there's some manifold in there.
Right,
So
right,
of the
right, right.
possible minds, if we restrict it to the subset that are generally intelligent, not all goals are on that. I would even actually take issue with the concept of a goal for a general intelligence, right? Like I think a general intelligence has a multidimensional goal, but let's just, for the sake of argument, say it could have single-minded goals. I'm saying that not all single-minded goals fall on the manifold of general intelligences.
If we redefine intelligence as optimization power, or if we just restate the thesis and we say arbitrarily
Mhm.
high optimizing power agents can have arbitrary goals, if that's another weak form of the orthogonality thesis, do you agree
Okay.
with that weak form?
So the way I would phrase that, if I'm understanding correctly, is we want to sub out general intelligence for just intelligence, right?
For general optimizing power, because basically you took issue with the definition of intelligence. Like in my definition of intelligence, I defined a paperclip maximizer as potentially highly intelligent, but you said no, no, no. By the definition of intelligence, I don't think it should count as being intelligent if it's really, really good at maximizing paperclips. So I'm like, okay, well, let's use a term that we both agree on its definition. So that's why I threw out optimization power.
Yeah. So, um, maybe can I phrase it this way, which is you can have very optimal paperclip maximizers. You can have very optimal paperclip maximizers, um, but there will always be more optimal machines that refuse to be solely paperclip maximizers.
Okay, so it sounds like you are disagreeing with the most recent weak form of the orthogonality thesis. So when I state arbitrarily high optimizing power agents can have arbitrary values, you're pushing back and you're saying, nope, the absolute highest optimizer power ones are never going to be paper clippers. Did I understand you correctly?
That's correct. Yeah,
Okay,
that
and
sounds
when I
about
say
right.
never
Yeah.
going to be, that's a statement about searching the
Well,
entire a perfect search through the entire algorithm space is never
yeah,
going to
yeah, yeah.
find a top level intelligence paperclip maximizer.
Really, what I'm trying to get at here is that even if those, exist in principle, or they're even there in reality, what I'm trying to say is they're a vanishingly small portion of the space of accessible minds,
Okay, but
right?
that's a very
So you
different claim,
can't you
right? A
can't
vanishingly small portion, that's a very different claim from it doesn't exist in the
well,
space of
then
possible
whatever.
algorithms.
Then take it as don't exist. I don't care. Like, I mean, if
But
you
that's a
really
very
are that
different
hung
claim.
up on, Why?
I think it's very interesting. Even the weak form of the orthogonality thesis, I think, is an important thesis. Like the claim that somewhere in algorithm space, there is an algorithm that is as intelligent as you want it to be, but also
Okay,
cares a lot
so
about
then
maximizing paper clips.
explain to me why. So for example, if I say the probability, is 0 of that existing versus the probability is 1 times e to the minus 30. Okay, what difference does it make to you for your argument, for your policy, for what? Like, what's the
The
practical
difference,
difference
the
this
difference is
makes?
that we can factor out how we disagree about the strong orthogonality thesis, because I think the probability is a lot higher than you think it is. But before we have that argument, let's at least both agree that it's not zero, because from a computer science perspective, there's a lot of branches of computer science that just talk about a single best possible algorithm and don't try to do probability of algorithms existing, right? It's a separate
Okay.
question of like, does an algorithm exist? And then we can have a separate discussion of like, okay, but will researchers ever create the algorithm?
Okay. So for the sake of argument, right? I'm going to continue to deny that it's possible for now. At least like I don't think you presented an
Okay.
argument that it's possible. Okay?
Okay. So,
But
so you think a
for the
perfect
sake of
search through
argument,
algorithm space is not going to find it? The probability is zero.
correct. Let's just
Okay.
that's what I think right now. You haven't convinced me otherwise. But let's suppose for the sake of argument, it's there with some probability. Choose whatever low number makes you happy. I want to know where you want to go with that for the strong orthogonality thesis. So let's suppose that there's 3 minds in the space of all possible Turing machines that are paperclip maximizers of the highest possible optimization power. Now what?
Um, so
There's
I
3
get
of
to
them.
assume I get to assume that they already exist.
No, no, not that they already exist. Like, oh, well, you can't make that claim. You can't possibly make that claim. Like, they're just in principle possible. We
Oh,
could
okay.
we could stumble upon one, right? So there's in the space of all possible Turing machines, there's some handful of Turing machines that are paperclip maximizers of the highest possible, optimality, but not generally intelligent.
Okay, I see what you're saying. Yeah. So, yeah, you're
Now
making a
what?
perfectly reasonable claim. You're saying, look, maybe all of these orthogonal agents exist. Maybe really smart agents that have really bad or really amoral
I'm not
goals
saying they
exist.
exist. They're
Yeah,
possible,
yeah, right.
and
Sorry,
not that they
they
exist.
exist in the sense of like being elements of the set of possible algorithms in
Correct.
a mathematical sense. Okay.
Okay,
Yeah, and
good.
then
All right,
you're
good.
asking a very reasonable question of like, okay, how will the universe actually evolve, right? What algorithms will physically exist compared to the space of algorithms that could exist in that mathematical sense? Very reasonable question. And for that, we have to dive into the question of like, well, how are the AI labs doing getting AIs to do things that we value, right? I feel like that's kind of an empirical question and also, try to
Okay.
extrapolate that trajectory.
Okay, well, I don't think we have time to get into that.
Yeah.
We should one day, but how does it relate to the strong orthogonality thesis? Because you told me that
Right, right,
if we
right, right.
resolve this, so we're now, for the sake of argument, we're in agreement that in the space of all possible algorithms, there are algorithms that are paperclip maximizers of the highest possible optimality, but not generally intelligent. How does that now bear at all on the strong form of the orthogonality argument, as
So the
posted
strong,
on
yeah,
lesswrong.com?
the strong form of the orthogonality on less wrong, which I endorse, is that I think there's a good analogy you can make, an accurate analogy, where if you want to guide an AI to have a utility function that cares about human stuff, it's analogous to the problem of guiding a rocket to go land on Mars for you. Like there is a lot of guidance required, and if you don't use the appropriate guidance, you're not going to gently land on Mars, right? You're not going to get an
Okay.
AI that cares about you. You're going to get an AI that cares about something else.
So that's the counting argument, though, right? So it's not enough that there's only 3 of them in this entire space. It's like there's so many of them that guiding it is a very treacherous course, right?
I mean, I think it's more complicated than the counting argument. It's an argument about like the nature of
Okay,
guidance, right? I mean, is it a counting argument to say it's
sure.
hard to guide a rocket to Mars? I mean, in some sense, yeah, but it's
Okay,
oversimplified.
sure. So I think like, and I heard it, and I forget who said this once, but I thought it was a great analogy. They said like, right now, the way that we're kind of uh, chimping along with our development of artificial intelligence is we're trying to land a rocket on the moon without understanding orbital mechanics.
Right. Yeah. It might even be sourced to Eliezer. He's got a whole post about that, which I love, by the way. He makes a lot of analogies
I think
between
Connor
getting
Levy
a
may
space.
have
Oh, okay. Yeah.
may have said that to me, but somebody
Mhm.
somebody said that. That's kind of what you're talking about, right?
Yeah, I'm going to link this in the show notes. Eliezer Yudkowsky has a great post called The Rocket Alignment Problem, where he really takes these analogies really far, and I personally love it.
Okay. Yeah, so I think, I mean, again, I'm not gonna buy the argument. However, I think the policy that it points to is that we need to be spending a hell of a lot more time and resources on learning AI mechanics, right? Or AI alignment mechanics. Like, that's where we would get to in terms of action that we should take. Is that correct? Or,
Yep.
okay. Yeah. And I mean, so I agree with that. I don't even need the orthogonality thesis to get to that point. I mean, we definitely, I mean, that's why I said I've been in favor of things like taxes and, civil liability and I'm not sure what else, but
Great. I think that's a good place to wrap it. What do you think?
perfect. Enjoyed it.
Yeah, likewise. So, yeah, I mean, to summarize, we tried to hash out our disagreement about Turing machines versus finite automata, models of computation. It feels like we didn't get far in convincing each other, but at least we exposed
We
enough of
didn't?
why we disagree that at least the audience can make up their mind. Fair?
Sure. I guess, I mean, yeah, I think we definitely talked enough that the audience
Yeah, I don't feel
can
like there's
decide
much
for
more we can
themselves.
say to each other, right? It's in the audience's hands now.
Yeah. Yeah, that's curious. Yeah. Okay.
And then I thought it was really fascinating to talk to you about, doomer topics because it sounds like, you're not coming in with a stuck position, right? You're willing to engage in arguments, you're willing to update your view. You have that
Oh, yeah.
larger background of like, yeah, life is fragile. Like we don't have plot armor, right? So we're coming at it
No.
from the same side of the table here.
No, absolutely. I mean, I think, and interestingly enough, I think even though we have obviously like quite different perspectives, we actually want the same thing of policies, which I think is interesting. I mean,
Yeah.
I think too much time is wasted on doomers and not doomers or whatever we're called, whatever labels, arguing about the differences in theory, right? Rather than just focusing on let's what do we agree with on policy? I mean, and just get it
Yep.
implemented sooner rather than later.
Absolutely. Great. And,
Yeah.
the fact that you came into the Lion's Den and you were such a great sport and you offered to have this conversation, I just want to let everybody know if I've ever done a reaction episode or named you in Doom Debates, you're automatically invited to do the same thing that Keith did. Come on over. You got a right to reply. We'll have a friendly back and forth and you can make your best case. And, I won't interrupt you or, maliciously edit or whatever. You can make your full unedited case to the Doom Debates viewership. Yeah. So,
Thank you for having me
Keith,
on.
yeah, thanks so much for coming on. Really enjoyed it. Hope to keep the conversation going. And I love the work that you're doing with machine learning street talk, by the way. So if you guys
Oh,
like
thank
Doom
you.
Debate, I definitely recommend at least checking out machine learning street talk because they're constantly putting out good quality discussions. And some of them I agree with, some of them I disagree with, but there's no question they're doing great work. Yeah,
I
thanks again.
appreciate it. Thank you.
Once again, I'm really grateful to Keith for agreeing to do this. I think the back and forth we had was super friendly and productive. It's not just about hashing out our particular disagreement, it's also about proving to the world that this is how discourse can work. That people with very different beliefs about something like the limits of LLMs, when the stakes are so high that whoever's right might have a much better mental model of how doomed we are, even in that situation, we can just have a friendly conversation anyway, and we can just honestly tell each other where we agree and where we disagree. It's not that hard. You just have to have the social norm and expectation that people do it instead of just retreating to their own camps. So luckily here on Doom Debates, we're starting to see a snowball effect where the show is getting more and more guests are interested in coming on, and that makes the show even more popular. And so by this time next year, I'm expecting a lot of very high quality debates, not necessarily all of them involving me. Sometimes I'll even bring on two other guests to debate each other. Because as you know, the whole mission of Doom Debates is to raise mainstream awareness and urgency of near-term AI extinction risk, and to create the social institution for high-quality discourse and debate. People like Keith who are coming on and being good sports, even without the social expectation that you have to do that, they're really helping the cause, and I appreciate it. Now, as for you, the Doom Debates listener, you have to do your part by not being a dick in the comments, okay? Normally, I'm proud of my audience. You guys leave mostly great, supportive, productive comments, but I have seen a few stray dickish comments go by, and I'm not going to tolerate that. So if you're being a dick to Keith in the comments, I'm going to ban you from commenting, okay? I'm not a pro-censorship guy. The last thing I want to do is ban. But if you can't follow basic rules of good discourse, if you feel like you have to be a dick instead of just arguing object level, then you can't comment in my forums, okay? Because it's too hypocritical to be like, yeah, let's have high quality discourse, and then have comments like, Keith can go to hell, no comments like that, okay? And it's really not even the right vibe because I like Keith. I like machine learning street talk. I like keeping the dialogue open, and Keith and I have a lot of common views and interests, as you heard. So thanks for remaining civil. And also, the other way you can do your part, in case you've forgotten, is you can smack that subscribe button. You can share this episode. You can do all kinds of things to get us to that 2,000 or 100,000 YouTube subscriber mark. Just when I was feeling so good about myself for crossing the 1,000 YouTube subscriber mark, one of my commenters was like, how come a thoughtful guy like you only has 1,000 subscribers and all these channels that are talking BS about how AI is great have like 1 million subscribers? And I was like, you're right. I'm getting screwed here. So let's help rectify the situation. By the way, if you went on my Substack, doomdebates.com, before this episode and you pledged a premium subscription of $10 a month, then you got to see behind the curtain of how I was preparing to talk to Keith and what topics I was putting into the outline. You got that kind of insider access, and you even got to tell me your thoughts about how I should approach talking to him. So if you want that kind of access, I don't just give that to anybody. You have to go to my Substack, doomdebates.com, and pledge that you're going to pay me $10. Just because I think it's good to maintain a separation of like the brain trust compared to the mainstream audience. I think it works well. And of course, 99% of the value will always go out publicly for free to the mainstream audience. But it's a really cool, unique, fun, productive experience to also have this brain trust of people who are tossing their Hamiltons at me. It's fun to do both. Thanks for watching. Keep your comments coming. And I'll see you on the next episode of Doom Debates.